Guys, I'm back. We're talking about the sine function and cosine function. In section 13-4 is concentrated on the sine function. Section 13.5 is concentrating on the cosine function. I'm going to talk about both functions first a little bit. Then I'm going to concentrate on how to graph the sine function. In this section, we're skipping examples 1 and 2. Instead, I'm going to show you how to graph the sine and cosine function. Obviously, I want you to go ahead and copy these two definitions for sine function and cosine function. And we're going to talk about what the graph looks like and where the numbers for the graph, the x and y coordinates of the numbers for the graph come from. So the sine function, y equals sine of theta. Remember, theta is the angle measurement. Sometimes the angle measurement could be measured in degrees. Sometimes it can be measured in radians. Like the sine of 60 degrees is the same as saying the sine of pi over 3. Okay, so same thing with cosine. Degrees or radian measures, it can be measured in either or. And if you look at the tables I created, in order to graph the sine of theta and y equals the cosine of theta, I use both degrees as my input, like the x coordinate kind of. It's like the input. The input is the degrees or the radian measures. I did the radian measures in red, and the degrees are in black. And then the output is what you get. The output for sine is the y coordinate of the point on the unit circle. Here's the degree measure, 60 degrees. The output is the y coordinate for sine. The output for cosine, again, the input is degrees or radians, either or. The output that you get is going to be the x value of the point on the unit circle. I did send some unit circles to you guys yesterday. From now on, we're going to be using the unit circle, so you should have one of these handy. I sent it on Google Classroom, so go ahead and check it out. Print one out and have it in front of you. It's going to help us to graph these. It's going to help us to solve some problems involving sine, cosine, tangent, cotangent, secant, cosecant, all the different trigonometry functions. Okay, so let's go back to this. I hope you're copying all this down. Cosine function, again, sine function matches the angle measure of theta, which can be at a measure, it can be in degrees or it could be in radians, to the y coordinate of the point on the unit circle. I just talked about that. Cosine function is very similar, y equals cosine of theta. Well, again, that one matches the angle measure of theta, which can be in degrees or it could be in radians, to the x coordinate of the point on the unit circle. I already talked about both of those. Here's some examples, and here's a little example drawing that I did. The sine of 60 degrees is square root of 3 over 2. And if you divide that, I think you get 0.86 or something like that. And the cosine of 60 degrees, or the cosine of pi over 3, again, pi over 3 is the same as 60 degrees. The distance from here to here is pi over 3. This arc here, that's where radians comes from. This degree measure is the opening from the initial to the terminal side of the angle. So the cosine of 60 degrees is 1/2. You can get all these answers on the unit circle. If I ask you what's the cosine of 120 degrees, you can come over here and say, oh, there it is. It's the x coordinate of the point after 120 degrees, which is negative 1/2. See that? What's the sine of 120 degrees? Well, that's 120 degrees. It's the y coordinate of the point on the unit circle at the terminal side of the 120 degree angle, which is square root of 3 over 2. You can do that for all these special angles that we have here. Again, the unit circle is very important. Make sure you have one handy. Okay, let's go ahead and graph this now. I just made the table for sine and cosine, so we're going to go ahead and graph it. Again, I used special degree measures. 0, 30, 45, again, in radians, 0, pi over 6, pi over 4, pi over 3, pi over 2, 90. Okay, everybody see what I did? After 150, I just skipped over to 180, 270, and 360. I didn't give all these. I didn't use all of these angle measurements. I did all of these. And then I skipped 180, 270, and then 360 takes us back to where we started. And then this is all the y coordinates you get at these different degree measures. That's the sine of theta. So at 0 degrees, you get 0. The y coordinate is 0. At 30 degrees, the sine of 30 is 1/2. Sine of 45 is square root of 2 over 2. Sine of 60 is square root of 3 over 3. Square root of 3 over 2. Sine of 90 is 1. Again, it's all the y coordinates. Sine of 120 is square root of 3 over 2. I'm just showing you how I built my table. The sine of 135 is square root of 2 over 2. Sine of 150 is 1/2. Sine of 180 is 0. All the y coordinates. Again, I skipped these, but again, that's the answers. Negative 1/2, negative square root of 2 over 2, so on and so forth. Sine of 270 is negative 1. The sine of 360 comes back to the beginning is 0. Again, that's where I got all these numbers from here. Then when I graph them, let's go ahead and graph them. 0, 0. At 30 degrees, that's the x-coordinate. The x-coordinate are the angles, and the y-coordinate are the y values. Okay? Sine of 30 is 1/2, so I'll go up here, put a dot at 1/2. Again, I've made it pi over 6 also. The sine of 45 degrees is square root of 2 over 2, which is a little bit more than the half. Just a little bit more than the half. The sine of 60 is square root of 3 over 2, which is about 0.86 or something like that. So again, it's going up. Then the sine of 90 is 1. The sine of 120 is square root of 3 over 2, is about 0.8 or something like that. Sine of 135 is square root of 2 over 2, which is a little bit more than the half. Sine of 150 is 1/2, exactly. And the sine of 180 is 0, so go down back to 0. Do the same thing here. It's going to be a bunch of dots. Sine of 270 is negative 1. Sine of 360 is 0. Again, if I follow this, look what I get. And it goes on forever. Again, it'll go on forever in both directions. This is a periodic function because the period repeats over and over again. If I keep doing the sine of bigger numbers than 360, it's going to continue with the same exact pattern. And that's the sine of theta, the graph of the sine of theta, the parent function. You notice where it starts. It's important. Sine always starts at the middle of the graph. Here's the maximum point. Keep that in mind. That's important. Here's the minimum point on this graph. And the max and min will keep repeating over and over again. The y values, look at all the y values. It's periodic because all the y values always repeat. 0, 1/2, 1/2, square root of 2 over 2, square root of 2, square root of 3 over 2, 1. These numbers will always repeat over and over again. That's what a periodic function is. Cosine is very similar, but look, if I look at the unit circle and if I plot these points, this cosine of 0 is 1. It's the x-coordinates now. The cosine of 0 is 1. The cosine of 30 degrees is pi over 6. Same as cosine of pi over 6. Square root of 3 over 2. Cosine of pi over 4 or cosine of 45 degrees is square root of 2 over 2. It's all the x-coordinates. Cosine of 60 degrees is 1/2. Cosine of 90 is 0. Cosine of 120 is negative 1/2. Cosine of 135 is negative square root of 2 over 2. So on and so forth. Cosine of 180 is negative 1. Cosine of 270 is 0. The cosine of 360, which comes back to the beginning. This is 360, by the way, also. It's 0 and 360, which is 2 pi in radians. It's the cosine of 360, or the cosine of 0 is 1. That's where I got all these numbers from. So you can copy that down when you get a chance. And let me go ahead and plot all that. At 0, the cosine equals 1. So look where it starts. Sine starts at the middle. At the origin, at the middle of the graph. This is the midline of the graph. The midline of the graph is the x-axis in this case. The max and min are here. With cosine, you're going to start at the max or min. Again, cosine, sine, if sine is positive, it starts at the middle and goes up. If it was negative sine, it would be the same exact graph, except it would be a reflection across the x-axis. It would start at the middle and go down, and then back up, and then back down. Cosine is positive. It's going to start at the top and go down. If it was negative, it would start at the bottom here and go up. So cosine is positive. It's y equals positive cosine of theta. Is the parent function of cosine. It starts at 1. And then the cosine of 30 degrees is square root of 3 over 2, which is 0.8. Cosine of 45 is square root of 2 over 2, which is a little bit more than a half. Less than 0.8. Square root of 60 degrees, cosine of 60 degrees is 1/2. And then cosine of 90 is 0. Cosine of 120 is negative 1/2. Cosine of 135 is, you can see that? Yeah, make sure you can see all this. Cosine of 135 is a little more than negative 1/2. Cosine of 150 is negative 0.8 or something like that. Cosine of 180 is negative 1. Cosine of 270 is 0. And again, I skipped some of these angles because it's going to be the same thing as these. It's going to follow the same pattern. And the cosine of 360 is 1. And you can see that it's this very similar type graph, except the cosine always starts at a max or min. Sine always starts at the middle. If that makes sense. Here's the max, the maximum point of the graph. Here's the minimum point of the graph. So cosine always starts at the max or min. Sine always starts in the middle. If it was negative, everything would be reflected across the x-axis. This starting point would be here at the bottom at -1, and it will go up and then back down here and end here. So it'll be the same thing except the reflection across the x-axis. Okay, now I'm going to skip example 1 and 2 because they're not that important, but they do talk about some important things. I'm going to go straight to example 3. Let me make sure I center this properly. Okay, I think I can zoom in a little bit. Yeah. Now example 3, and again, I'm going to end the example 3, then the next video will have example 4 and 5 where we actually graph them. Example 3 is asking find the period of the sine function. Here's the formula for it. The period is 2 pi over b, and b is the number of cycles from 0 to 2 pi. Remember, a cycle is one complete pattern. Look at this graph that we have here. This is the graph of y equals the sine of 4 theta. You can graph this on your graphing calculator. What they did here is we graphed it from 0 to 2 pi, and the sine of 4 theta happened to have been all these different cycles all the way to 2 pi, from 0 to 2 pi. And then we also went from 1 to -1 because this is the max and min. 1 to -1 were the max and min. The question in example 3 is how many cycles are there in this graph sine of 4 times theta, 4 theta. So whatever the angle measurement is, just multiply by 4, or whatever the radian measure is, multiply by 4. That's what we're doing. Well, how does that affect the graph? Well, instead of being one cycle like we saw, 2 pi is the same as 360, by the way. It's the same as what I just graphed. 360 degrees is 2 pi. Remember the last one when I graphed the sine of theta, the sine of theta by itself was one cycle. Looks like this. The sine of 4 theta has many cycles. Question in A is how many cycles are there? Well, let's see. A complete cycle starts and ends in the same place, remember? This complete cycle starts here and ends here. This is one cycle from here to here. That's 1. Got it? Let's see if there's another one. There's another one. That's 2. Let's keep going. Oh, 3 cycles. Keep going. 4 cycles. There are 4 cycles here, so the answer is 4. There's 4 cycles. That's the answer to A, example 3A. Okay? Now it says, now that we know how many cycles there are, how does that relate to the coefficient of theta equal 4? The coefficient of theta, which is 4. Here's the coefficient of theta. How do you think that relates to the coefficient? Well, there's 4 cycles and this number was 4. I guess this number tells you how many cycles there are. Right? This number in front of theta tells you the number of cycles. Good. So now we know what this number is here. The coefficient of theta tells you how many cycles there are. There were 4 cycles from 0 to 2 pi because of the 4. If there was no 4 there would have only been 1 cycle from 0 to 2 pi, which is, again, 2 pi is 360 degrees. It's one complete spin around the unit circle. Find the period of y equals sine of 4 theta. Well, period is the length of the function from here to here, the whole length, the distance, which is x2 minus x1, the x coordinates. Again, it's like the theta, these numbers here on the x-axis, divided by the number of cycles. I guess the number of cycles is going to be b. b is going to be the number of cycles from 0 to 2 pi. That's what b stands for, number of cycles from 0 to 2 pi. And we said it was 4, right? And then to do this, 2 pi, x2 minus x1 is 2 pi minus 0 over 4. What's the same as just 2 pi over 4? Now let's reduce that 2 pi over 4, and what do we get? Put the answer down here. It's going to be pi over 2. Pi over 2 is your answer. The period here is pi over 2, and look at it. You can see up here why it is. The period is the length of one cycle. The length of one cycle is 0 to 2 pi. It's 2 pi. From here to here, the length of the cycle is from pi over 2 to pi. Again, it's pi over 2. The length is the period of one cycle. All these cycles have the same length of pi over 2 units. Again, remember pi over 2 is 90 degrees. Okay, that's example 3. Now I want you to do quick check number 3, page 136, A and B. There are two graphs there. They want you to do the same exact thing we did in example 3. Let's do example 4. Oh yeah, we're going to do example 4. Example 5 and 6 are the ones we're going to do tomorrow. So example 4, and then we're going to end this video. And then the next day I will do example 5, 4 and 5 on another video. And then I'll give you homework after I'm finished with the whole section, section 13-4. And then 13-5 is going to be doing the same thing, but with the cosine of the cosine function. Example 4 is this. Just making sure that everything is lined up right. Yeah. Find the amplitude. So we found the period. We found the number of cycles, and that helped us find the period, which is the length of one cycle. Okay? Now we're going to find the amplitude. Remember the amplitude, if you remember, the amplitude was 1/2 the, when you find the length from the max to the min, it's 1/2 of that, remember? So the amplitude is the distance from the middle of the graph to the top, or the middle of the graph to the bottom, to the min. That's what the amplitude is. And how do you find that? So if we look at the formula, y equals a sine of b theta. B is the number of cycles. Theta is the angle measurement, the input. The output is what you get when you solve it. A, the number in front of sine, is the amplitude. Here, sine of 4 theta, there was no number in front of sine, so that I guess the amplitude is 1, and let's see if it is 1. The distance from 0 to 1 is 1. The distance from 0 to -1 is 1. And it's the absolute value of A, because distance is always positive. Even though it's negative, it's always positive. So from here to here is 2, and half of that is 1. That's how you get the amplitude. Well, let's apply that to here. Y equals sine of theta. What's the amplitude? Well, here, the blue graph is the sine of theta. And you see how there's one cycle from 0 to 2 pi? Because there's no number in front of theta. There's no coefficient here. It's 1. That means there's one cycle from 0 to 2 pi. And we want the amplitude. There's no number here, so the amplitude has got to be 1. Let's just see. What's the distance from here to here? From the maximum to the middle is 1. The distance from the middle to the minimum is from 0 to -1. It's 1. The amplitude of y equals sine of theta is 1. Again, you can do this. You can say the max minus the min. 1 minus -1 is 2. The distance from here to here, from max to min, is 2 units. And divided by half, divided by 2, or multiplied by half, you're going to get 1. 2 divided by 2 is 1. So the amplitude of y equals sine of theta is 1. What's the amplitude of y equals 2 sine of theta? Here's the graph of y equals 2 sine of theta. I just graphed it for you. Well, the only difference is, instead of the max and min being 1 and -1, the max and min are 2 and -2. That's what the 2 did. It told us what the max and min were. Well, amplitude is half the max and min. The distance from the max to the min is 2 minus -2, which is +4. It's 4 units here between the max and min. And divided by 2, you get 2. Or you can simply go from the middle to the top is 2 units. That's the amplitude. The middle to the bottom is, from 0 to -2, is still 2 units. Again, the amplitude is 2. So here, y equals 2 sine of theta. The amplitude is 2. Remember, the amplitude is half of the whole distance from the max to the min. Or it's the distance from the middle to the top, to the max, or from the middle to the min. Again, the distance there is vertical, so you're really subtracting the y values, y2 minus y1. Or you can just look at a graph and just do it that way. When you're finding periods, you're doing the horizontal distance of one cycle, and that's going to be subtracting the x values. When you're doing amplitude, you're subtracting y values because you're doing vertical distances. Now what I want you to do is quick check number 4, page 136, A and B. So right now I want you to do quick check number 3 and quick check number 4 on page 136, A and B, A and B. And then tomorrow I will post another video for examples 5 and 6, and we'll be done with this section, and then we'll start section 13-5. Thanks, guys.